To Bal Vigyan Bharti with your mentor Vilas Sarkar. As you know, we have already started a new subject, that is matrix in mathematics. There we have reached while we are discussing a different kind of matrix. In that we have already described two kind of matrix, that is row matrix and column matrix. Let us move to the other kind of matrix. So our the subject is coming under kind of matrix, and there we have already defined row matrix which contains one row and the columns are not specified. Columns are not specified, but it won't be less than 1. At least one column must be there, then only we can say it is a matrix. 1 cross 1, if there is one element that is holding the row as well as the column, then also we can call it a matrix, but it should not be less than. Then there is no existence, because we cannot think of a matrix without any value inside. At least if I put any value, let's say 2, it will contain the row as well as the column. So the least, from the common sense we can say, the least of the number of columns cannot be less than 1, but we don't have any upper limit. It could be anything, but the row number for a row matrix has to be 1. Okay. So the next one was the column matrix. Similarly, where the limitation is in column number. So column, that we explained, number of column is 1, and the rest of the things just the reverse for the case of row. There is no limitation, but the number of row must not be less than 1. So that was the case. So this was the earlier two. The third one, if I say that is not in the same order that I am discussing, maybe in any order, but these are the kind. Your unit, or it is called the unit matrix, or it is called the other name is your identity matrix. Okay. So this name is bit people can guess what kind of matrix, but with the identity matrix people may not guess. So you have to remember both the names simultaneously. Unit matrix and identity matrix, although it's same, but by this name is not possible to remember the things. But unit, if you know it, what is that matrix is look alike, then with this you can automatically bring back your memory. So if I see as per definition, the main diagonal, you know what is main diagonal? Main diagonal elements are 1. Whatever be the size or the order of the matrix, the main diagonal, all the main diagonal elements are 1. So if I give an example of 2 cross 2 matrix, so and this is an extension, other elements are 0. So this is also to be mentioned, because only saying 1 it will not fulfill the case. Other elements, the other position, whatever the positions there, apart from the diagonal elements, all other elements has to be have to be 0. So that means if I say the 2 cross 2 matrix, this would be the unit matrix. And if we give an example of 3 cross 3, so then this would be the case where other elements, other position elements are holding 0. Only the main diagonal or the diagonal elements has to be 1. So this is the case of unit matrix, and the same thing goes with identity matrix. These are called also the identity matrix. So you have to remember by the name. Okay. The fourth one is null or zero matrix. So from the name also you can guess what kind of matrix is this. So yes, all the elements are 0. So value of all the elements are 0. That means if a matrix is being represented 2 cross 2, this is something like that, or even if we matrix of 3 cross 3, this would be the case. Okay, so this is a 3 cross 3 or 3 by 3 matrix. Okay, so this is null matrix. So this could be this says as a any number in algebra, any number, let's say n, if it is multiplied with 0, will get 0. The similar for the case of null matrix, if say A is representing the null matrix, okay, null matrix of any order is a square matrix, then definitely is m by n. Then and if I have some same order of matrix, let's say m and m of same order, so when we will multiply a and b, as in algebra, if I assume that this is a, this is b, and we are getting 0, in matrix also we will get another matrix, let's say C, this will be a null matrix. Okay, now as we are multiplying m cross m, all the order are same, so this has to be also the same order, but you will get a null matrix. Okay, so this is the case with the null matrix. The next one, the application of all this I will discuss when I will discuss the numericals. So as of now, just understand what is that by definition, what is it, so that you need to know first. Then after, when the application will come, then you can understand definitely what is the use of this kind of matrix. Okay, so don't be very anxious right now, or don't be too much confused by seeing all this different kind of. Just keep it in mind, and slowly we'll progress so that we can understand it in a better way. Okay, don't be in a hurry. Sometimes may happen that students are if half filled with of knowledge on any subject, and they try to go towards the end of the subjects where he needs some help. So not only that, maybe you have knowledge, but if you follow the way it is progressing for any classes or anybody who is teaching in any subjects, so try to get all the details what he is teaching or she is teaching. You don't jump up to the end or conclude somewhere at the end. So the basic things you will miss. So whatever people are teaching in a way, they are starting with from the very basic, and basic is always needed, although it seems to be very easy and very casual of teaching. So whenever a new subject is there, try to get all the essence of the subjects, even if it is very introductory, very means initial stage, basic stage, but those are very much you can say the foundation of knowledge for any subject. To get a good grip on the subject, you need to know all these basic things also. So don't miss anything. Wherever you are following, whatever you are following, follow from the start of the subject to the end of the subject. Don't jump somewhere suddenly. Okay, so this is my advice for any students who are sometimes the students are very energetic and very sharp. They can understand and think quickly, so they feel disinterested while the things are going very slowly. So but don't do that, because if you really want to learn a subject, you have to learn all the things from the basic, from the introductory to the end. Then only you could have a good grip on that, and wherever you will try to teach someone, or you have to get some application regarding that subject, it will be very confident approach then. Okay, so okay, on that note, the next one is rectangular matrix. Okay, so what is that? The generally any matrix can be, in general form, can be of any size, any order. So that means what I'm going to say, that if a matrix is A represented by that alpha, this alphabetic with a suffix, you can say, if the suffix, as I said, I and J will represent the row and column, and it is order of m cross, let's say, P, or n cross n, if I say. So it's not that it always have m is equal to n. Okay, this is some specific case where m could be equal to n, but whereas m and n could be of different value. So if m and n not equal to, m is not equal to n, so that means there you won't get the number of rows and number of column equal. There could be always a different of numbers. So if m is different, m is number of rows, the number of rows could be different, number of columns could be different. So that will make a shape if it is that elements are equidistant. So if we place the equidistant the elements to each other, so it could take a shape of this or this. So this kind of matrix representation is called the rectangular matrix. So that means overall, if I define a rectangular matrix where you can say the number of rows not equal to number of columns. Okay, so this could be the simplest definition for a rectangular matrix. Next come just the kind of a rectangular matrix where, as I said, that if a matrix is given by this m cross n, if m is equal to n, then this could be a specific one where if both the arms of any arrangement of a geometrical figure which is a rectangle. Now a rectangle, if this and this are equal, this will convert into a square. So that is the same thing. If m and n are equal, so m become n. Okay, so then both the arms are same. So the arrangement, if the elements are equidistant, so this will form a square. So definitely you can say, in case of square matrix, the kind of matrix is square matrix, and this if I define where number of rows equal to number of columns. Okay, so this is going very simple. So just for remembrance, you have to remember all this kind. Okay, So the next which will come as 7, if I say this is diagonal matrix. So what is that diagonal matrix? It says if any one of the diagonal element is non-zero. Now if I say this, any one of the diagonal element is non-zero, that means what? If I think just the opposite or the companion part of this, anyone, so that rest, anyone, the opposite is rest. If anyone is non-zero, the rest is 0. We can say non-zero opposite 0, anyone opposite rest. So that means if I say I have a matrix where there is 3 cross 3 of matrix where any one of the diagonal element is non-zero. So that means this is the diagonal element. There could be 3 of the part. In that, let's say non-zero means any value you have to put, and rest is 0. So that means all the part remaining I can put 0. Okay, so this is the minimum requirement where diagonal any of the diagonal elements. So that means there is an extension of that. Any of means all 3 could also be non-zero. So the other possibilities are all 3 could be non-zero, or any 2 of these non-zero, or at least 1 is non-zero. So there are probability 3, if it is 3 cos 3, 3 or 2 or at least 1 is non-zero. But at the same time all other elements have to be 0. So this kind of matrix is called diagonal matrix. Understood? Okay. So if it is this I have given an example of 2 cross 3. If it is 3 cross 3, if it is 2 cross 2, so then there are 2 position of diagonal and rest. Now we will talk about the diagonal elements. So follow the main diagonal. There could be this diagonal, or any short diagonal. But when we talk about the diagonal elements, that means we are talking about the main diagonal only. So you should not be confused. That I have described in my last video. Wherever we will talk about the diagonal elements, that will define the main diagonal, and main diagonal starting from the left top to the bottom right. This is the main diagonal. Okay. So now if it is 2 cross 2, there are position where the elements could be non-zero is 1 or 2. So at least any of the thing you can say, if it is non-zero, then also this could be a diagonal matrix. Fine. Okay. Next comes your, so the next is number 8, and the number 8 is the variety transpose matrix. Okay. So now what is this transpose matrix? Okay. So if I define transpose matrix, it says the transpose of a matrix is when we will replace rows with column elements. Okay. So to understand that, we'll take some example, and this time the example I will take the general example of a matrix. Means what is the general example? The matrix with its universal form, that is the form of rectangular matrix. Because if I take with square matrix, there will also always be a doubt in students' minds. So what about the rectangular? So original form of matrix, you can say the rectangular matrix, where number of rows not equal to number of columns. So let us take some matrix of kind 2 cross 3, where the elements are such D, E, F. This could be a numerical value. We can try with a numerical value, but where I am just seeing it as a generalized form to make it more understandable. So what would be the transpose of this? Now the transpose is represented as AT. So if we say what is the representative of transpose, any matrix power T is the transpose of that matrix. So if I say that A is the matrix, so A to power T would represent its transpose. So you need not to say by words, only this representation is enough. So A transpose is when, what I said, you convert, what we do, we replace the rows with columns. So but how can it possible? Now this row, if I follow, there is 1 and 2 row, and is 1, 2, 3 columns. So row, if I see, there are 3 elements. So if I replace rows with column, we replace rows with column. So column having 2 elements, here are rows having 3 elements. So it is only possible when, if I see this order must be changed. How come? Rows having 3, instead of that I would put 2. What are those? A and D for the first row, because we are changing rows with column. So column having this much of value elements, so this can be accommodated there. The third one will not come, so definitely the thing will change here. Similarly, this will be this one, and this will be this one. So now see, if I say the transpose is of this kind of matrix, the order is just reverse. This 2 of 3 order, the actual matrix, this has been changed to 3 cos true. Understand? So now this is clear that when a matrix, if it is of odd order, that means it is not of equal order, that means this is not of a square order. Better to say like that. If it is not a square matrix, if it is a rectangular matrix, the order is reverse in its transpose. Understood? So we will divide the matrix. When it is being transposed, it will change its order or reverse its order, and the number of elements in the column will be transposed to the number of rows. So that way the replacement is possible, where the number of elements in the rows or number of elements in the column, it is placed in rows. Other way around also can be possible. This definition, if I say this is my element, so let's be this is my element. So if this is my element, so if I take transpose of this, let's say I'm giving it a name of B. Now if I want to get B transpose, so what would be the case? As per the definition, rows will be replaced by replace rows with the columns. There is columns having 3 elements, there is rows having 2 elements. So now we have to replace it in the column, in the rows. So this will become again this will become again this. Now if I assume this is B, and B transpose is just, this is 3 cross 2, now this is 2 cross 3. We will come back to the same order as this one, and element, if you see, it is matching with A, so you can say this is A. So now one thing we have proved by this process, that A transpose, A is transposed to some value, let's say B, some, if I can name it B. Now if I do the transpose of this again, I will get the original matrix. So what does it mean for us? What does it mean for us? It is, by that process we have proved something, that A transpose the first operation, then again we have transposed, we are getting back the original matrix. So if I do the transpose of the original matrix, then again, so two consecutive transpose of same matrix will bring back the matrix again. So we can write two consecutive transpose will bring back original matrix. Okay, so this is one property of, you can say, the transpose. Understood? Okay, so the transpose is when we replace the rows with columns, the elements of the rows with elements of the columns, and by the process of discussing, we have already proved that transpose of a matrix, if it is done consecutive twice, I will get back the original matrix. I will end up here. We will go bit slow because this is a very new subject and nowhere it is related to other subject that I taught. So that's why I think it will be very good if someone is following me very closely. For him or her, it is definitely useful if I go bit slow for a new subject, so that if that basics has to be very much pretty much clear to every students. That I am again saying again and again, don't skip or jump to any part of the subject straight away. What I am teaching, I am going very slow and I am moving from the foundation of the subjects. So this is my intention, so that it will be a longer learning or longer you can say the gain for students. So be with me the way I am moving, so you will definitely get profit out of it, that I can assure you. Thank you for now.